welcome to the video where we're going to look at converting decimals, fractions, and percentages, which are really important for some consumer math applications, especially when they're involving percentages. Consider the following statements from some news reports. A total of 13,000 newsroom employees, 2.6% of the newsroom workforce lost their jobs. The company's stock fell 15% last week to $44.25, and the new battery lasts 175% longer than the older one, but costs 10% less. In each of those statements, a percentage was used in a different way. So in the first statement, here we just have the 13,000 newsroom employees and 2.6% of the newsroom workforce lost their jobs. So we're expressing a fraction of a total workforce. In the second statement, the company's stock fell 15% last week to $44.25. The percentage is used to describe a change in the stock price. And in the third statement, the new battery lasts 175% longer than the older one, but costs 10% less. We're using a percentage to compare the performance and the cost of the batteries. Let's talk about converting fractions to percentages first. So here we have a fraction, 67 over 100. When we're converting to a percentage, percentages are based on 100, right? So we learned about the prefix per, or the word per, which just means to divide. And cent, think of, cents, like there's 100 cents in a dollar, or century, which refers to the number 100. So you're just taking a number and you're basing it off of 100 or dividing by 100. So when we have a fraction and it's already, the numerator is already being divided by 100, we're just going to divide the numerator by the denominator. And here we get 67 divided by 100, which if we do that, we get 0.67. And if I want to convert this now to a percentage, I'm going to multiply by a 100 and add the percent symbol. And anytime I multiply by 100, I'm essentially just moving the decimal to the right two places. So we end up with 67%. So whenever you want to convert a fraction to a percentage, you're just going to divide the numerator by the denominator and then multiply by 100. Remember, the numerator is the top part of the fraction, and the denominator is the bottom part of the fraction. And then we're going to multiply by 100. And of course, add the percent symbol. How do I convert decimals to percents? Well, here you already have, in the first example, when we converted the fraction to a decimal, we just had to go one extra step and multiply by 100, or move the decimal two places to the right. So really, that's all we're doing here. We're taking the decimal and we're multiplying by 100, which again just moves the decimal point two places to the right. So we get 89.3%. So anytime you want to convert decimals to fractions, you're just going to move the decimal two places to the right, which remember is just multiplying by 100. And then last but not least, let's say we want to convert percents to decimals. So now if you think about it, we're kind of going backwards, right? We have the percentage. How do we get back to a decimal? And what we're going to do here is instead of multiplying by 100, we're going to divide by 100, which will move the decimal two places to the left. And then, of course, we're going to remove the percent symbol. So pretend there is a decimal point here after the 35. I'm just going to take that decimal now and move it back two places, which is really 35 divided by 100. So we get 0.35. For 1/2%, you know that 1/2 can be written as 0.5. So again, if I use that same reasoning and I remove the percentage, and then I move the decimal back two places to the left, you end up with 0.005, which is 1/2%. Let's look at some problems where we need to solve percents. In daily life, we may need to know how to solve any one of the following three types of problems involving a percentage. In this first example, we're asked to find a 15% tip on a restaurant bill of $45.71. So really what this question is asking us for is 15% of $45.71 is what number? And I know that 15% is 0.15. Of means multiply, so I'm going to multiply by 45.71. And then is means equals. What number is x or n? It's some variable, it's our unknown. So if I multiply 0.15 times 45.71, I end up with $6.86 rounded to the nearest cent. So that would be how much tip you'd want to leave if your bill was $45.71 and the tip was 15% of that bill. In letter B, if Nancy sells a car for $19,000 and receives a commission of $475, what percent of the sales price is the commission? So here, we're basically asked 475 is what percent of $19,000. So using the same logic that we used before, we've got 475, and then if I convert this to algebra, is equals, what percent is my variable, that's my unknown, and then of means multiply, and I'm going to multiply by 19,000. So if I'm solving for x, I need to do the inverse operation to isolate the x. Since I'm multiplying, the inverse is divide. I'm going to divide both sides by 19,000. And when I divide 475 by 19,000, I get 0.025. Okay, the question says what percent? So we know to convert decimals to percents, I'm just going to multiply by 100 or move the decimal to the right two places. So I know that the commission 2.5% is the percent of the sales price. In letter C, if the price of a laptop computer is reduced by 35% or $341.25, what was the original price of the computer? So really, this is just saying 35% of what number is $341.25. So again, I need to convert a percent to a decimal, so I'm going to divide by 100, which will just move my decimal back two places to the left. Of means multiply. What number is x? Is equals, and it's equal to 341.25. And to solve for x, I'm just going to do the inverse operation of multiply. I'm going to divide. And when you divide 341.25 divided by 0.35, you end up with 975. So that must have been the original price of the laptop, because 35% of that would be $341.25. What I would like you to do is pause the video and try the next three problems on your own, and then you can unpause it when you're ready to move on to the next topic. So in this topic, we're going to look at percent change, which is really used for comparing changes in price or population or anything involving percentages. For both percent increase and decrease, it's essentially the same formula. So you can have a percent increase, which is just the amount of increase divided by the original amount. And for percent decrease, it's the amount of decrease divided by, again, the original amount. So we're always dividing by the original. Let's take a look at how we would use this. So in 2000, the world population was approximately 6 billion people. The figure shows world population projections through the year 2150. The data are from the United Nations Family Planning Program and are based on optimistic or pessimistic expectations for successful control of human population growth. In this first example, we need to find the percent increase in world population from 2000 to 2150 using the high projection data. So high projection, we're looking at this blue graph. So it's projecting that human population in the year 2150 will reach 30 billion. So I need to figure out the percent increase. So to do that, I'm going to take the new value minus the old value, which would be 6. Okay, remember these are in billions. And I'm going to always divide by the old or the original, which is 6. And here I have 24 divided by 6, which is 4. Okay, and I'm going to now multiply that by 100%. So we should add that onto the formula. I'm going to multiply that by 100%. So that means that there's going to be a 400, the projected increase in world population is approximately 400% by the year 2150. From, considering from the year 2000. I'd like you to pause the video and try the next problem related to the graph, and then you can unpause it when you're ready to move on. Let's take a look at some other applications of percent. So we'll look at sales tax and discount. Many applications involving percents are based on a formula A equals P times B, where you can think of it as like A is P percent of B. Okay, so what percentage of B is A? We can take this formula and kind of tweak it to sales tax and discount and other formulas. Okay, let's take a look at sales tax. Sales tax is, a lot of times it's money collected by states, counties, cities on sales of items. There's sales tax on, many things like clothes and different items you could buy. There's sales tax on hotel purchases. The sales tax is the percent of the cost of an item. And there is a formula for it. So it's essentially this formula, A equals P times B, but we're going to kind of tweak it. So the sales tax amount is going to just be the tax rate, right? When we're dealing with rates, we're dealing with percentages. And it's the rate times the item's cost. My problem says, suppose the local sales tax rate is 7.5% and you purchase a mountain bike for $894. We want to look at two things. How much tax did you pay and what is the mountain bike's total cost? So I'm going to apply my formula here. I'm first looking for how much tax is paid, and to do that, I'm going to take the tax rate times the item's cost. So my tax rate is 7.5% of the total cost, which is $894. And we know we want to convert 7.5% to a decimal. So I'm going to drop the decimal symbol and divide by 100, which is just moving the decimal back 2 places to the left. So really it's 0.075, and then times, of means times or multiply, 894. And when I do that, I get $67.05. So that's how much tax I need to pay. Now, when you're paying for the mountain bike, the original cost was $894, but now I need to add on the sales tax. So when I'm looking for the total cost, it's going to be the item's cost plus the tax amount. So the item's cost was $894, and the tax amount is $67.05. So the total cost of the item is going to be $961.05. You can try practicing a sales tax problem on your own, and then you can unpause when you're ready to learn about discount. So not everyone is always thrilled about sales tax, but we do like buying things that are on sale. And from time to time, businesses reduce the prices or they discount to maybe attract customers, to reduce the inventory. The discount rate is a percent of the original price. So again, that formula A equals P times B. Okay, so we're going to, again, tweak that formula, and we're going to find the discount amount, which is found the same way you find tax. It's a percentage of a base price. And this time we're calling it the discount rate. Remember, rate is percent. And we're going to multiply that by the original price of the item. So a gaming laptop with an original price of $1,460 is on sale at 15% off. What is the discount amount? So remember, that discount amount is a percentage of the original cost. So here we're looking at 15% of $1,460. So what that means is I have 0.15 times 1460. And when you multiply that out, you get $219. So that's my discount amount. So if I want to find the sales price now, in order to do that, we're going to take the original price, and since it's discounted, we're going to subtract the discount amount. So the original price of the laptop was $1,460, and we're going to subtract the discount, which is $219. And if I subtract those, I get $1,241. And that's it for this first lesson. In the next section, we'll look at some ways to take control of your finances and look at ways to budget and reflect on our spending habits. Have a great day, everyone.